All right. Something wrong with cameras again. Okay, today we are continuing with transformations of functions, but why don't we go review what we did on Friday quickly. So we learned 6 transformation methods. The first 4 was translations. Basically, you shift a graph of a function up, down, left, and right. When you have a number added to the very end of the formula or subtracted, it goes up and down respectively. Positive means up, negative means down, right? So when does it go left or right? If you have plus, minus a number directly affecting x values right next to x inside the function, then we have right and left shift. If it's negative, it's right shift, positive, left shift. Okay, and we have seen on Friday stretch and shrink. There are 2 types, vertical or horizontal stretch and shrink. If you are talking about vertical shrink, you need to have a number less than 1. If you want stretch, you need to take a number greater than 1 right in front of the formula. You have a main body of function like absolute x, the number should be in front. Small number shrinks, big number stretches. However, it's the opposite when you have a horizontal case. The number is right in front of x, it's influencing, affecting x values. Then we have big numbers shrinking it, small numbers stretching it. Okay? Alright, and today we are going to learn our final transformations, which are going to be reflections. There are 2 reflections. One is, you see the black curve? Somebody made it upside down. They reflected along x-axis. First one is reflection along x. The second one is reflection along y-axis. 2 types. Y-axis is this axis, x is this one, right? So 2 types of reflections. We're gonna check out when they happens. Here is the rule. The rule says if you have a minus put in front of the formula, entire formula took in a parentheses, and you put a minus in front, then we reflect it along x-axis. Make it upside down. Upside down. Okay? If you put the minus only in front of x, each and every x taken away and put it back with a minus in front, then we are reflecting it along y-axis. Side to side reflection. Left to right, right to left. Okay? So along y-axis is a side reflection. X-axis is kind of upside down reflection. Okay? Does it make sense? So put these 2 on the list, and we are going to summarize them in a minute anyways. It's going to be all compiled in this list. So this is kind of the final product of this section. But that's all we need in this section. Alright, stretch, shrink, translations, up, right, left, right, up, down, left, right, and then vertical x and y reflections. That's it. Okay, our first problem is number 9 today. Double check, it's still the same, yep. It says, take this graph, this is given to you, and do this transformation to it. What do you see? What did they do? They took all x's, it's not anymore g of x. Do you see g of x here? No. But instead of x, they replaced x by negative x. Okay? So what happens if you put a minus in front of each and every x? What kind of reflection was it? Y. So you're going to reflect this along y to the other side. Alright, it's a lot easier if you just track these edges. There are 3 dots here. Just reflect them and see where they go and combine those 3 points. So I'm going to reflect this one first. Can you read me the coordinates of this? Which is 2, -4. So when I reflect it to the other side, it's going to become -2, still -4. Alright, how about this one? 1, 2, 3, 4. 4, comma, -1. When I reflect it to the other side, it becomes 1, 2, 3, 4, -4. But still -1. Y coordinates do not change. Okay, how about this one? When I reflect this, where is it gonna show up? Here? Same place. Anything on the y-axis remains on y-axis, okay? So here are your 3 dots. Just combine them. We're all done. Let's pick the right choice. Seems like it's D. It's not A, B, or C. Wait. It's none of these. Oh, because this problem is different. Sorry. Yeah. Okay. But anyways, I can still do it. Take these 3 points this time to the right. Yeah. It looks like this picture is the answer below. We are reflecting it back. So it's now this one, D. Okay. All right. I believe we have a y-axis symmetry coming up next. There is this graph given, and what are we doing with it? Oh, somebody put a minus in front. When you have a minus in front, what kind of reflection is it? X-axis. It's x-axis. So I'm going to just make this upside down. So reflect this point, it's gonna go here. I don't need to compute the coordinates, but if you do it, it's fine. -2 to reflect it and find it if you wish. Where does this blue point go? Stays the same. It's on x-axis. If you reflect it along x, it remains on the x. And that's 1, 2. I combine these 3. It's this half. I'm sure it's another problem here. So we're kind of solving a brand new one now. Yeah, they are reflecting our earlier question along x-axis. This is gonna go up and make a upside down V here. Okay, just like I'm pointing out. So the correct choice here is D. Right? Okay, here is the summary of what we did so far in this section. Put this in your note sheets as well. I mean, this is kind of the core of the subject in this section. If you have numbers on the end, it shifts up or down depending on positiveness and negativeness respectively. If you have minus and plus, it's right and left shift respectively. If you have a number in front, big number, stretch, small number, shrink. If a number in front of only x, shrink if it's big, stretch if it's small. Reflection is along x-axis if you have a minus in front of the entire function, but if it's only minus in front of all x values, then it is y-axis symmetry. I'm sorry, reflection. Any comments? Questions? Again, this is in your books. Don't worry about copying it. But until you can do things on top of your head, have this when you're doing homework on the side so you can always double check. Alright, now when you are doing mixed transformations, transformations involve a lot of steps, stretch, shrink, moving up or down. Order matters. You need to start with the right transformation first. Okay? So which one is first? This order is important. We need to do first horizontal transformations and then vertical transformations when you're doing it. Okay? But within horizontal transformations, we always start with, if there exists a shrink, stretch, or reflection, we do one of them first. Again, any kind of shrink, stretch, or reflection is done first. Okay? Then we do horizontal shifts. And then we start vertical ones. Shrink, stretch, and reflection is again first. Then we do shift at the very end. Okay, here is the story. If you have a number on the very end of the function, like this one, this is always last. No matter what, it's last. Okay? Next. So that's the story I get. This is easy. I always take care of this guy last, because it's on the very last, right? Very end. Then we have only 3 to compare. We always start with things that's happening to X. It's very important. Whatever shifts, transformations are happening directly to X, it's gonna be done first. So so where are those? There is a number subtracted here from X. That's the only thing happening to X. I need to do this first. Right? If I had another number right in front of X here, like 2X, I would do this 2X first. This would be then second. Alright. If you don't mind, may I slightly change this question? Now I will revert back to original. I want to put a 2 here, or 3, let's put 5. I want to put a 5x here, so that I can have all 4 transformations present now. All 4 are present here. So I always start with what's happening with x's. X's are here. And among right next to x there are 2 numbers. So which one is first? Shall we do -2 first or 5x first? The one that's closest to x. Is 5 closer to x than 2? Yes, we start with this one. This is first. This is second. And then between 1/3 and +6, I know already this is last. And this is third. Okay? Actually, there is a minus sign here. This is third. This is fourth. This is always the last, as I said. Again, between third and fourth, can I do fourth one first and third one next? Yes, you can flip the order there. You're free to flip order between third one and fourth one. But I like to take care of, I don't know, maybe the first one. It doesn't matter, it's your preference. But 1/3 and minus exist there. Okay? You choose which one first. It's up to you though. This guy is last. Again, this order, I'm following this order over here. Horizontal transformations are first, or whatever is happening to x is first, then whatever is happening to the entire function, they are last. Alright, so we start 11, but I want to take this question. It's -1/3 x minus 2 plus 7 instead of plus 6. So may I make this couple changes? First of all, there is a minus sign here. It's barely visible, but it is a minus, and I want to make this 7 as in the question. Okay. All right. Now, how many transformations? Let's count again. 1. So this is first. 2 and 3. I want to take care of this second, and this is third, and this is last. Well, can I take care of minus before 1/3? Sure, but I don't prefer that way. Is my order okay? Does it fit to this? Yeah. Good news, there is no number directly in front of x. There is a number 1/3, but it's not in front of x. It's in front of the main function x squared. So it doesn't count. There is no number in front of x, so it's gonna be relatively easier. Alright, before anything else, you need to name what's the main function we are transforming here. Absolute x, cube root x, 1/x, what is it? What does this function look like? It looks like one of them. Which one? There are 8. Which one shall we transform? X squared. This function looks like just x squared, right? Okay, so here is what I do. I go step by step. I'm going to take a big x and y axis plot here. I first put x squared there, this guy. Alright, here is x squared. This is x squared, right? Now, what is our first transformation? It's a right shift. How much? 2 units right. You need to move this blue dashed curve 2 units to the right. So this guy used to be 0, 0. It's now going to be 2, 0. I still put it in dashed form though. Almost. Okay. So this is x minus 2 squared. I took care of this part now. What is second one? Second transformation is, what does this do? Who can explain it? If you are confused or have no clue, check out this one. It's 1/3 x minus 2 squared. We are doing this. We are doing this one. Which one of in the list explains what happens to 1/3 main function? 1/3 times main function. Which one? It's this guy, right? There is a number in front of our main function. But which way? Which way? Stretch or shrink? 1/3. Because it's like 0.333 when you take a calculator, compute 1/3, and 0.333 is less than 1. So it's a shrink. I'm going to shrink this vertically about 1/3 times. Okay? So it's going to get wider. Shrink means get loose. This is too tense, too much pressure. It's stretched. We are gonna get it loose. So I'm going to get it loose like this. Okay, so this is 1 over 3 times x minus 2 squared. I don't need the very old sketches anymore. Should I clean them? I don't know. But you guys don't clean them, okay? In the exam or something, I need to see where you started and etc. But I can clean here. Alright, the green one is our now the graph after the first two transformations. Coming up next is who? The third one is negative. What does negative in front of the main function do? What's that? Reflection, but along? Yes, it's along x. Yes, and negative in front is a reflection along x-axis. So we are going to make this upside down. Same width, same height. Nothing changes on the graph, but it just becomes upside down. Now it has a negative. Okay? And the last one. What happens if you add a number to the very end of the equation? What happens? It moves, shifts where? You all see that? Vertical. So this is a vertical shift. This 2.0 is gonna go up 7 units and make 2.7. Okay, and this is our final graph. Any questions? Alright, let's pick the right choice then. Which one seems like the right one? A, B, C, D. Should be pretty wide, right? So it's not A, it's not D, C or B. We know it was the peak point was on the first quadrant, 2, 7. 2 and 7 looks like this peak point, so it's B. Again, do not peek at these solutions or options. Just do it blind on the paper, find the result and go pick the right answer. That's the right way to do it. Because on the exam you won't have these options. It's just gonna say apply the transformations and graph this function. Okay, this one is a tricky one. This last one, it's -4. It's not gonna make a big difference, but in the question it's -4. Okay, now what transformations do you see here? Okay, I didn't mention, but this is extremely important. Do you see if there is any number directly affecting x, they separated that x and that number with a parenthesis. If there is a C, another transformation is happening to x. If there are two double transformations happening around x, you need to create a parenthesis first. That's extremely important. We didn't care about it in this question because there was only one transformation happening to x. If there was 5 here, I will separate that 5 and make a parenthesis there. Okay, so this is the case where there are two transformations. One is in front of x, the other one is right after x. So what I'm gonna do is factor this number in front of x, factor it out from the entire expression. So here is what I need. Take this minus and make a parenthesis. So it's like minus 1 removed from x. It's just x. And I need to remove a minus 1 from minus 4 as well, and it's gonna turn into positive 4. Okay? This is essential. This is important. Otherwise you can make a mistake. If this was, for example, minus 5, I will make this 5. 4 over 5th. When I multiply this, 5 and 5 cancels, okay? Or if this was 2, I will make this 2. 2 times 2 is 4. Always remove the number in front of x, okay? And take a parenthesis. Alright, anyhow, it's just a minus in this question. Okay? Now, let's identify the transformations. I see what do I see? Oh, I cannot remove this. Okay, we're good, no problem. So what is this? A minus directly affecting x values. What kind of transformation is this? A minus affecting x values only, not the entire function. It's not here, this is different. It's inside together with x. It's a y-axis symmetry. So it's a, reflection. So there is a reflection happening, so this is first. And that's a y-axis reflection. Okay, so why don't we do that one first, and then we will take care of 4. But what is the main function first? What main function has been taken and changed? Perfect. Square root x. So I'm going to plot that one first. Here is square root x. Again, this is in the first 2 slides if you forget their graphs, but you need to know them by heart. Okay, this is root x. And what do you want to do with it? You want to bring an minus in front of x here. So when I put a minus in front of x, it's going to reflect along y-axis, and it's gonna go this way. Okay, this is root negative x now. Okay, here comes the $1 million question. Somebody took x away like this. It used to be minus x. They took a wipe out. They cleaned this out. And then they replaced it back with this area, this ghost area now. It wiped out. They replaced it with x plus 4. I mean, they increased the x values. They added 4 to each and every old x spots. So what kind of shift is this? It's a horizontal shift. Which way? Right or left? It's a left shift, yes. So this is positive. That's a left by 4. Okay, so I'm going to move this 1, 2, 3, 4 units left. This is my final answer. Okay, minus x is gone. Instead you have x plus 4. Alright, let's pick the right choice. I mean, most general mistake is people think it's a minus and this is a right shift. No, it's not a right shift because x has a negative in front. And you consider that negative, it's actually a positive 4. That's why I took the parentheses out, okay? So this is a left shift and let's pick the right one. So which one is the right choice? This is right shift. Is it A? B, right? 4, 0, negative 4, 0. This is negative 4, 0, negative 4, 2, 4, 0. It's B. Okay, another way to check you did right or wrong, just make sure this point satisfies this equation. Plug in minus 4 here. When you plug in minus 4 here, do you get 0 or not? Minus 4 is positive 4, negative 4, 0. Yep, it checks. Just take this value and enter and compute if it makes 0. It does. So this question, I need you to take a look at home again. I mean, you're going to do it in your homework anyways. But it's one of the tricky ones. People usually fall into trap and shift it right because of the negative 4. But it's not actually negative 4 there. When you factor out minus, it's positive 4. Okay, we're done with this section. Any questions about transformations? Right, left, down, up, stretch, shrink, reflections. That's it. But when they combine, it can be confusing. Yes?
For the other equations, do you still factor out the negative? If there would be parentheses, an absolute value?
If, again, yeah, if it's an absolute value or something still, yes, you need to. Again, when do we factor out that minus or any other number? If you have two transformations at the same time happening to x. Here we did it, but here we don't have to, this one, because there is only one transformation. There is no number in front of x. Okay? Yes, even this is an absolute value or cube root, other main function, you still factor out. I mean, if the question was not this guy, but if it was v of x negative x minus 4 squared plus 10, I would still factor here. Okay? But there is sometimes help. If you factor minus here, you can turn this, it becomes positive. And then when you take this minus out, it turns into positive because of the square. Because when you pass the square into minus 1, x to the 4 minus 1 square is positive 1. The question turns into better format, x plus 4 square, okay? But here, you cannot take minus out of square roots. Can you move minus out of a square root? No. Okay? Because we don't know square root of minus 1. It's a complex number. Again, if it was an absolute value, you were safe. Because when I take a minus out, it becomes positive. So you can use the properties of those nice functions. But our hands are tied here because we cannot move this minus out. Alright?